So hi everybody and welcome back. This is C++ tutorial series for absolute beginners. This is video 264 and in this video we talk about virtual destructor. But before we can talk about this virtual destructor, we have to talk about destructor in general and how they are used in classes. And to do so, we jump to the destructor page and read here a little bit through. So first of all, let's start here on top with the first sentence. It says here, a destructor is a special member function that is called when the lifetime of an object ends. And before we go on, let's clear what is a special member function. Sorry. Because we know already what a member function is. It's just when you have a class and you have a function, it is considered to be a member function. But what is a special member function? And to do so, we click here on this link, we jump then here, and when you scroll here the member function sections a little bit down, you will find a section where it says special member function. And when we read this, it says here some member functions are special under certain circumstances. They are defined by the compiler, even if not defined by the user. They are default constructor, copy constructor, move constructor, copy assignment operator, move assignment operator, destructor, prospective destructor. And it says here also special member function along with the comparison operator are the only function that can be defaulted. Okay, that is defined using this one here instead of the function body. See the okay, this is okay. This is an additional thing, but important. First of all, you see from these special member functions, we have already talked about the default constructor. We know that when we create a class, we don't have to provide a constructor. The compiler will create automatically, it's called implicitly, a constructor for us, and that is exactly this default constructor, for example. But we see also now the compiler is creating much more functions behind the scene which we don't be aware till now. For example, we have never talked about this copy constructor, move constructor, copy assignment operator, move assignment operator, and the destructor. And you can see we will have to talk of all this one step by step through the class, because we are not finished with classes at all. But today we are talking about the destructor here. So now we know what a special member function is. Let's jump back and read here a little bit more. And it says here this special member function that is called when the lifetime of an object ends. This is special for our destructor. So when the lifetime of an object ends, what does this mean? A lifetime we learned already a little bit. For example, we have here a scope. Let's say this is our scope. This is not a good example. For example, most time we have a function scope, you know, this scope symbol here, this curly braces, it starts here and then it ends here. And when it goes out of the scope, the lifetime, whatever, ends. But not careful, this is a class, it's not a function. It's behaving a little bit different. All right, we know this from functions normally. And we know you can then click on this one here and read also here lifetime. And there are not only scope lifetime, there are other lifetime. And we talked about this storage duration, automatic duration, and all this kind of stuff a little bit, not in detail, I think, because you can see here it's a little big. We went not through this one. Anyway, now we know this destructor is called when we destroy the object. Let's say we have created this object here. You can see here is a example. You create here an object, then it is free the object here in this example, and here's the end of the scope main function, right? After this one here, this object B is destroyed. Careful, don't confuse with delayed. Delayed means not destroyed. Delayed means free. And destructor is destroying this object B here. And that will happen when the compiler reaches the end of this function main here, for example, or when it's in another function, end of the scope of the function. All right, so that we learned now too, that the destructor is automatically called, but important, like the constructor here, the destructor must be not automatically called, which means you can, as a programmer, provide it as well. And you can see when we go here, here they have provided a destructor and here a virtual destructor. So we can provide them like the constructor as well with the destructor, but most time they are not providing it because normally you don't need to provide a destructor, it works. But this is not the case with virtual functions. If you have the word virtual in it in a class, it is better to provide this one. We will talk this a little bit in a moment, but let's finish a little bit here more about this destructor in classes. So we learned now it's a special member function. It is called when the lifetime ends, the object get destroyed. We know it is, we should not confuse it with the word delayed. And now it says here the purpose of the destructor is to free the resources that the object may have acquired during its lifetime. Yes, we know that when we create an object, the compiler is allocating automatically memory, or you are allocating memory. For example, with this version here is the programmer is allocating memory and we have to free it. But in general, when you don't use the word new, then the compiler is automatically allocating memory and then it is freeing this memory again automatically. That's why the compiler is creating all time automatically this destructor after an object is destroyed to free this memory. Okay, and then there is some special cases in the constructors too where it is not automatically freed this memory, and this is this version here. When you see a destructor must not be a coroutine. When you click on this one, coroutine, it says there are special functions which may be temporarily deactivated but can be reactivated, and we talk about this one in other videos, so because it will be go too far. Just know there are special functions which are not destroyed immediately because they are just inactive for a short time and can be reactivated. All right, so let's go for the destructor syntax a little bit, and the destructor syntax is very easy. Let's say this one here we already know from constructor. Here's the class name like a constructor. Then we have here this function symbols, this round square brackets, and then the semicolon. But the only new thing about is to indicate this is not a constructor. It's a destructor. It's this little, I think it's called tilde. I'm not sure. The symbol here, this little symbol here. All right. If you see this little symbol, it's a destructor. This is the version 1. Then we have a version 2 with the keyword virtual. That is second one here, which we will talk in a moment. And you see the same thing. This part is the same, and they just added in front virtual. Let's jump here to number 5 before we talk about 3 and 4. And in 5, when you watch closely, 5 and 2 are similar. It is even similar to this one here, 1. Why I say similar? Because this attribute is optional. Declaration specify sequence is optional. ID expression, okay, this one you have to give, and this ID expression is actually this part here. This one here. So this one you have to provide anyway. It says here when you go here to ID expression, read a little bit this one here. And you see we have to make this one and a little bit more. So this one is here, we have that. And then we have again this round square brackets, which we have another optional option here, which is this void, which we can also put in here as an indicator. And then exception is optional, again attribute optional after this one, and require clause is optional. We have not talked about here some attributes, for example this one here, but don't worry, I wanted to only show you that this one and this one are similar. And you can see that, for example, with that one I can just create this one here. You can see, let's say I just don't use that, I use that here, and when I jump to declaration specify sequence here, you can see one of these words are virtual. So I put virtual here, and then I go to ID expression. ID expression is, like I said, this one here. So you can see it's this one here. Oh no, this one here part, and then this one here I use, and this one I just skip again because it's optional. And that's it. And then I skip the other ones too, just so. And then you can, that's very nice to know. But here, let's talk about number 3 and 4 as well. Here is this word default, and we learned something here in the special member function. We can default them, right? Only this kind of function we can set to default. And when we set to default, this one means you can see we provide not a body for them. Normally when we have a function, because constructors and the special member functions here, which are listed, are also considered as normal functions, but not normal. They are special because they are used in classes. But important is, because they are functions, they should have normally a body. And this case, they don't have to, because we can use this default thing here. And we learned a little bit about this word default. When you use this default, you are indicating to the compiler, I want to use this one as a default for readability, and the compiler make behind the scene a better optimization. Instead, when you use, for example, a constructor with default, of course we can use a default constructor, or let's say we can create as a program a default constructor too. We have talked about it. It's just without the word default. It looks similar like this one, just without this, just this one here, and then we provide a body. And this is then not so effective because we are providing a body, and the compiler would optimize a little bit different than when we write it default. So this default here means just for better optimization and for selection later, if we have here perhaps more constructors provided. Then we have also not talked about this word delayed so far. Delayed means just don't use this constructor here. The question is why I would use here the delayed, because sometimes the compiler will try implicitly use, for example, here in this case a destructor, and you don't want it, then you write delayed. So the compiler can't access this this destructor or any other special function here which you have assigned delayed. Sometimes it tries to get this one or this one, and if this says, oh, it's delayed, I can't use this. But then you have to provide another efficient way, so that, for example, if you have used here a destructor, if it's delayed, then you have provide another destructor which works for this object, or you get a problem because, like I said, the compiler tries to destroy this object while it because it wants free the memory, and if it can't find a destructor here, then you have a big problem, because that would cause a problem, at least a compiler error. In the worst case, it shows nothing and cause just a bug. That's why careful about kind of stuff like that. Then let's go on. So, and here we have talked about the syntax. Now we know we have a destructor, and I will skip now here this parts here. You should read the explanations, and here are the parts. Let's go a little bit over it. So again, explanation here is talked again about the lifetime, which I already said. Then here it's talking about when the program terminates, the storage duration, then delayed expression, and so on. And stack unwinding, we have talked about this also a little bit. Yeah. Read about this explanation on your own, then read about this one as well. Prospective destructor, it is just here a little bit explaining here, so on. Then this one here is that what I already told you, implicitly declared destructor. Like a constructor, a destructor is implicitly declared, like this example here on top. You can see we see no destructors. The compiler will all time create a destructor, and all the other operators here actually too. We are not seeing them. The other ones are also created behind the scene. So this is created implicitly. Read a little bit this through. Then we have here delayed, implicitly declared destructor. That was this this word delete here. Then you can read a little bit how this is used more in detail. And then trivial destructor is just special case of a destructor. When it fulfills this criteria, it is considered to be trivial. It's not so important right now, but read it so that you can distinguish this a little bit from others. And then here, implicitly defined destructor. So you are wondering, wait a minute, this one and this one looks similar. Careful, it says here declared, here defined. And we know you can declare one, so you have not a body. And here you have here a body, something like that. Right, so you can read this one. This is just the only difference, body and not body. For a destructor, we will see an example. Can I see an example here already? Yeah, you can see here we have a body, for example. No, here is a body for a destructor. Normally, a destructor is all time implicitly created by the base. We never see an outcome here, but of course you can make something like this as well. Especially for learning purposes, you can put out a message, this was destructed, and so see if the object is destructed. And then the destruction sequence, that's a little bit important. So the destruction sequence, it's the reverse of construction. So when we have talked about a constructor, how an object is constructed in, and important here, in derived classes, for example. And if you go the other way around, you if you want destruct an object, you have to go the other way around. You can read this one. It is so in short, it's just saying destroy the first item which you constructed, and then go back where the last item what you constructed, and so on. But you can read this one, you will see this one. And then we are in virtual destructors. Actually, this is the part which we are talking here. And we can talk about this one as well, because you can see it is just a little part here section. And it says here, deleting an object through pointer to base. That is exactly that one here. So you can see we have here a base, we have here a derived. Here we create a pointer to the derived, so we make a pointer from base to derived. But important is we use the keyword new. Why we have to use the new word key? Because we are allocating memory, and when we allocate memory, we are using pointers. We learned this with the new keyword, right? And in this special case, it says here, also this is this one here. Also, deleting an object through pointer to base invokes undefined behavior. What? So if this case happens and we have not a destructor like this one here provided, we get a big problem. And that's the reason why I have to talk about this virtual destructor, which I skipped last time. But now we know that this is danger. So we have to provide a destructor. Unless the destructor, and then it says here, also invokes undefined behavior unless the destructor in the base class is virtual here. So we have to create in the base class a virtual destructor. Careful, this is not a constructor. You can see here is this symbol here. This is a destructor. And now it goes here, class derived public base. It is deriving from that. And then here we make, again, this is the same example like this one, similar to this one here. Again, a base pointer to this one. We learned this one. Why we make this pointer here? Because we want to use normally virtual function. That's why we make from base a pointer to derived. And then we can use virtual function, which we all time talk till now. And here it's special that we are allocating memory. And allocating memory is very important. Then we are using delayed. This word delayed, we know when we use the word keyword new, we should use the word delayed as well when we want free this memory, and they are using it. But the problem is here, you can see they are freeing all the memory by deleting this pointer here. And this pointer is pointing to this object here. And we learned something, that when we create, for example, anything like derive, and we have any object here, then it will be created as well, and this memory will be not freed. So let's read here a little bit more. A common guideline is, and that's also interesting here, it says here, a common guideline is that the destructor for our base class must be either public and virtual, or protected and non-virtual. And here is a link on this side. You have to click on this one. So, and when you click on this one, you can see I already have opened up here. It's the same here. Here is, you can see an article, and you should read this article and try to understand it a little bit. And this article is describing, at least anywhere here down, why this should be either public and virtual, or protected and non-virtual. But I say, for starters, there is even an easier rule than this one, and probably not absolute correct what I say, but it's easier, and we will see if it works or not later in detail. So let's read now the section here in virtual destructor again. It says here, even though destructors are not inherited, so we are back to our virtual function section, and now virtual destructor a little bit more in detail. It says here, even though destructors are not inherited. So that's interesting. Destructor, this one here, we have here two destructors. We have a base class destructor now, it's virtual, and then we have a derived class destructor here, and it says this one is not inherited, this one and this one, even so I use inheritance here. This one is not content of inheritance, so that's very important. If a base class declares its destructor virtual, yes, it is declaring its base class as virtual. The derived destructor always overrides it. Oh, so this one here is overriding this one here. All right. That's strange a little bit. Why it's strange? Because they just said this inheritance is not working for destructors. But still, it behaves like it is working. At least it seems so, right? And we just consider, yes, it is overriding it, to make it simple. And then this makes it possible to delete dynamically allocated objects. And this here, this sentence, what was again a dynamically allocated object? Actually, exactly this one. When we allocate memory, not the compiler, we make this with the keyword new. We are allocating a memory. And now we have this problem. Allocated objects of polymorph. Here comes a new word, a very important word, which you will hear a lot of time. This word polymorphic type through pointers to base. First of all, let's before we go to this word polymorphic, let's go here to this again. So this here makes it possible to delete here this allocated memory for this class as well. Because when we create this one here and this one here, and we make a pointer to the derived class here, this one will be created as well. And when we delete B, what happens normally? We are freeing only this memory normally. We would only free this class B here. The problem is, when I free this one here, that's okay. What happens with this one? So the point is, if you have not a virtual destructor here, this one will be just not freed. This one stick to your heap, for example, right? We learned this. This is created on our heap, which we have to free, right? And that's a big problem. To solve this, they made it here virtual, and this one here, it's then inheriting. And this one here will be called first before it will be called this one here, which means here again, let's go here again. I mean here to the second one. This one is created, so this both is created in our heap. And now I say, okay, I'm finished with my work. Delete this B here. Delete the pointer, which is pointing to the base. But because the compiler jumps in, it says, okay, I see virtual base destructor here. and now it is provided. Normally we know most time it is not provided. We never saw it till now, but here it is provided, and it is provided as virtual. The compiler says, okay, now I know I can't destroy you. I have go on to the next one and check what was created here, the other one which was created, and then it goes here and says, oh, I find a derived one. I destroy you first, and then from here it goes back, and then it destroys the base. So first of all it calls this here, and then it calls this, and then both are freed, and that works only with this word virtual destructor here. And that's why this one is very, very important actually. And the reason why it's so important, because this here can happen a lot, because we know where the heap is bigger in size, and classes, we don't know how big they can be. So it's possible that we will make pointers to or allocate memory and use pointers to classes. That's very highly possible. Most time not in this demonstration codes here. You can see these codes, what they are providing us. They are just for demonstration purposes and so on. And but in general, this one happens. Oops, where I am. This one will can happen, and because it can happen, it is a good practice. First of all, you can read this article again, what I showed here, either public and virtual or protected and non-virtual. Instead of this one here, I'm not so sure if you should make this one, because he makes sure that you never create here. You are never allocating memory here with the second one. That's why I think it's better for starters. Just when you see we are using a class, just any class here, let's say this one here, and it has the word virtual in it, then just create a virtual destructor as well. Okay, this is, I think that's easy for starters to use, and later when you are advanced and know all details, then of course you can choose a little bit easier if you really need it or not need it. But right now I would say, if you see just the word virtual in the base class, at the same time create a virtual destructor like this one here too. And that's all time. And the only reason why we are doing this is because we don't know if this class which we created is in the future used for allocating memory with a pointer. Perhaps not, then we are lucky, but if yes, and we have not a virtual destructor, we causing probably a bug or leak memory and whatever. That's why my tip, just see if you see virtual, the word virtual in a base class or anywhere, just create at the same time a destructor, a virtual destructor as well as a starter. You have not to follow this one, but it makes your life easier when we have it, and the best part, it will cause not a problem. All right, I think that was that for this video. And if you have any questions or any other comments like all time, write in the comment section. See you in the next video, where we have still to talk about this virtual functions a little bit more. But you see, we get better and better even with this complex examples here. So see you, bye, and like all time, have fun and never give up.